Hi guys, welcome back. This is part 3 of the Sansui restoration project, and today we are focusing on driver board repair and recap. In the last video I replaced the speaker relay and cleaned all the controls and switches, so if you have missed those parts, please check the links in the description. As you can see, I progressed quite a lot, but still a few things to do. First of all, I do apologize for delaying in posting repair videos. I went on holiday and was busy with work and family stuff. So let's pick up where we left. In the last video we discussed about heavy distortion, and I said that I was suspecting that the issue seems to be located at the driver stage. Indeed, I was right. These are the culprit, two SA726. These bad boys are notorious for shot noise, crackling, static noise, whatnot. I did not check whether both of them failed or only one of them. Because they have really bad reputation, I replaced both of them without second thoughts. And the issue was fixed. For those who did not hear the noise I'm talking about, the distortion I'm talking about, please watch the part 2 of this series. Right then, so in this video I'm going to show you how I did it. I followed some basic troubleshooting method. As I said before, this is my hobby. I'm not expert or professionally qualified. But just want to share my experience, especially for those out there like me who just starting this hobby and not coming from electronic backgrounds, but enjoying servicing this kind of vintage gear, right? So troubleshooting wasn't difficult, to be honest. So I went through kind of an elimination process. First thing I did was to identify if the noise coming from both channels or either left or right. In my case, I could only hear from the left channel with or without feeding any signal, so the right channel was working perfectly. Next step I did was to find out if the noise coming from the preamp or the main amp sections. By doing this, I can either focus on pre or the main amp areas, right? So in this unit you can easily separate those modules, use of a switch, and most of the other models have jumpers, right? If separator selected, basically you are decoupling preamp from the main amp. While I was testing, I switched to separated and the noise was still present. So from that point I knew that issue was located at the main amp and should either be in the driver stage or the output stage or the power stage. As far as I know, it's very unlikely the power stage goes bad. Those output transistors are rock solid. So next thing I did was to check service manual. Lucky me, it has schematic of driver and output stages. This is the one. As you can see, this is the layout of the left channel. Clearly indicates positions of each components, including two SA726. Not only one, but both of them acting as a diff amp. Because I was planning to change them anyway while I was recapping the unit later, if these guys were the problem, then I had 50% of chance of fixing it. And also driver board come loose very easily, like pretty much every other part of this model. So it wasn't a big deal, even though the issue was not fixed, right? But funny enough, my guessing was right. These were the problem. So let's take a look. Before pull the driver board, you need to take the connector behind this cover, right? Once it's done, you can turn the unit over and you have 2 more screws. Most of these connectors have keys, right, to prevent mistake while putting back. But I like to mark them either way, I know exactly where they go. The board come out easy, just pull it out. To identify left and right channels are easy as well. The board is kind of divided into 2. Obviously each components and positions are printed, so basically TR1 and TR3 is for left channel, TR2 and TR4 is for right channel. I always kind of like to mark the components to be removed, just to avoid turning back and forth a couple of times. The beauty of this model is most of the boards comes out like this. I would say all of them. Much easier to do it. You don't need a fancy desoldering gun. Right, here we go. Both of them are out now. Just for fun, let's check the gain of the old ones. Not sure if they will match, Bear in mind I don't have a curved tracer, which is probably the right way to match transistors, but I'm using this DCA 55, which is good enough. Let's check the first one. We have 282. Let's do the second one quickly, and we have 339. Keep in mind I just removed from the board. Obviously heat was applied with the soldering iron, so I wasn't expecting a close result anyway, but I don't think they will match. Right, I'm gonna replace with KSA 992s. They are the recommended substitute for 726, 725 and many more. I'll put 2 transistors with close gain match. So the new one have been matched already, and I'll post that video shortly, but just to show you, they are very close, if not almost the same gain. So let's check. The first one is 443 and the second one is 441. You see, pretty close. When installing a new one, you need to be careful with the orientation. So the KSA 992 have a different pin order. If you look at this data sheet, you'll see that leads are in a different order. In the 726, it goes from base, collector, emitter, but in the 992s, the orient is other way around. So emitter, collector, base, right? So if you look at the before, both the left and right channels have original 726, and they're all facing downwards, right? However, after I change, you see the KSA 992s in the left side are facing upwards, right? So that's it. You know, long story short, basically all you have to do is to install them in opposite direction, right? Alright, all done, new one's in. Let's put back everything together. Before turning on the unit, I always use the dim bulb tester. No matter how careful you are, you could make small mistake and cause bigger damage, right? This saved me a couple times now. This is your friend, guys. As you see, there's no short. The bulb dimmed as expected. Right then, this is it. So I'm really happy. As I said, the distortion is gone after the replacing 2 transistors, and now I'm going to replace all the capacitors. So stay tuned. Right then, what I'm doing here is drawing the board layout. So basically taking notes of all the capacitors are coming out. I mark their positions, values and orientation. This way I know I have very little margin for errors. Another option is take pictures, but I prefer this method, to be honest. You're gonna need a lot of pictures and can be also hard to read at the end, you know. What I normally do is take 1 or 2 pictures of the whole board and draw the layout, right? It makes more sense to me. So the next thing is to remove the nasty glue, which is a pain in the backside. I'm using this sharp knife. Luckily only 4 of those caps are glued. Everything else looks fine. Not sure if you can see, but that nasty glue has eaten leads of a resistor and a diode. I tested, they still reading good, and carefully clean as much as possible without breaking them. But not sure how long they will last. I'd better off ordering new replacement, I guess. Actually, I'm going to start with the smaller caps and leave the big ones in place until the end, so I can simply turn the board over without and start desoldering without any support, right? Right, if anyone is interested on the list of replacement cap, here's the table. Bear in mind that some of the small value caps are no longer available to buy, so I have replaced with them with VMA film caps. You will also see some of the voltage ratings on the newer ones are slightly higher because I could not find the exact values, but when it's come to the capacitance, I always replace with the exact values, which is I think the most important pair. So sit back and relax and enjoy. I see you shortly. Right then, that's it guys. I'll release remaining repair videos as soon as possible. Please stay tuned. I hope this was useful. As always, please subscribe and hit the like button to help to grow this channel. Until then, goodbye.